Hi, this video helps you understand how to use your knowledge of 3D vectors and your knowledge of trig to solve these sort of real-world type problems. Okay? The first thing we want to do is, when we're drawing our 3D axis, label it as best you can. All right? We know that y plus represents our northern direction, x plus east. Remember, think about z plus sort of going up in the air. We're flying, we're jumping, we're doing whatever. Z minus, we're diving into water, we're going below ground. Now, you're probably not going to draw this grid because it's too time consuming, but I want you to think about this grid as the ground, right? A piece of graph paper that we're sort of just tilting at an angle. It's still flat, okay? So let's read our problem, all right? Lena throws a javelin due south, right? That's going to make her life very easy. At a speed of 18 miles per hour at an angle of 48 degrees relative to the horizontal. Okay, so the first thing we're going to do is we're going to draw that, right? Draw that vector, okay, for our javelin. And what I want you to think about, before you start, I'm diving right into this, right? But what I want you to think about is, what is your strategy to solve this? Right? We're first going to find our vector for javelin. There's a wind factor. We're going to find our vector for wind. And what it's ultimately asking us is, find the vector that represents the resultant velocity of the javelin. We have two forces, right? The javelin and the wind. And we know that when we add vectors, that's going to give us the resultant. Let me spell that properly, huh? Okay? Okay, so that's going to be our strategy here. Okay, so let's start. All right, when I look at this, I can see that my y component is going to be negative because I'm going south, and my z component is positive. X is 0. We're actually on the y-axis, and we know that on the y-axis, x is 0. So now which function are we going to use? I know we're used to saying on a 2D axis, x is cosine, y is sine, but you have to figure out, again, a drawing helps. I can see here that cosine is actually y, all right? And z is going to be sine. So we want to be very thoughtful about which functions we use. Okay? Now let's look at the wind. The wind is saying, we are traveling at 12 miles per hour at an angle of south 15 degrees east. In this case, since there's no z component, if we're in standard position, we're imagining that the wind is flowing horizontally, meaning there's no z component. All right? 15 degrees east of south is something like, right, like this. All right, and again, in this particular case, we want to see what's happening. Right, I can still see that my y component is negative because I'm going south, but my x component is positive. Now, here's the difference here. Again, we said that our z component is 0. I want you to be very thoughtful here. If I look at the way this is drawn, x is actually sine, and y is cosine, okay? Now notice what I did. I drew an xy axis because if there's no z, it's easier to see what's going on a flat surface. Again, if I was going to draw that vector for the wind, it might look something like that. All right? So we want to be really thoughtful about how we're going to draw this. Now, once we have our vectors, that's the easy part. We're going to use our calculators and we can find our javelin vector, our wind vector. Now, our resultant is simply the addition of those two, right? So add your x's, add your y's, what's that? 23.63. Add your z's, that's 13.38. Notice this is in component form, which matches our answer in unit vector form. Okay? I hope that helps. Have a good day.